I just got used to it with the screen here, you can see.
Up to you two guys. And we're no big rush. 2.5 hours. That's great. I think
Right. Our next speaker is Martin Farach-Colton. He is now the department chair at NYU, and he has been doing theory research for a long time, and he has applied a lot of this theory research to systems. So he's going to talk a little bit about that.
Thank you, and thank you for the invitation to speak. I asked, what should I speak about? And they said, oh, how to do research when you're a theoretician, how to work with systems people. So this is not a technical talk. This is a talk about how to do research with systems people when you're a theoretician, and cultural differences, and all kinds of anecdotes, and so on. There'll be a small amount of technical stuff, but don't expect theory or systems in here. All right. All right, let's see. What do I do here?
Or you say the other thing to the other community.
What is this talk about? The good, the bad, and the ugly of cross-disciplinary research. And also a little bit about how to start a company. Suppose the good thing happened and you actually got some really good stuff done. I went around to my colleagues and I asked them technical questions about how do you start a company when you're a professor, and none of them knew the technical answers. So there'll be a little segment in the middle about what happens when you hit a home run and you have a company, and I'm afraid that this only applies to the US. So for those of you who are not from the US, hopefully there'll be enough jokes in that section that you won't nod off to sleep. Yeah. What is this talk not about? Pretending that all cross-disciplinary interactions work out. I said to a friend of mine who's nicer than me that I was going to have some snarky anecdotes in my talk about interactions gone wrong. He says, oh, don't do that. Upset people and so on. And I said, well, Kunal and Kirk invited me knowing what I was going to do. So this is not going to be Instagram where you only get the pictures of the things that worked out and everything's nice and all vacations are perfect and so on. Sometimes things go wrong. You need both positive and negative examples. And I think if you're a junior person just starting to work in cross-disciplinary research and everything doesn't look exactly like all the good examples, maybe you'll take it personally, but don't take it personally because most of these interactions don't work out. So what should I think about when doing cross-disciplinary research? First thing I wanted to do was talk about, for a theoretician, types of experimental research. If you're sending something to experimental algorithms conferences like SIA or AllenX or things like this, you're going to do experiments that answer algorithmic questions. You have some question about the behavior of some algorithm, and you're going to test that in isolation. And then there's sort of the default database sort of thing. You typically build a data structure and argue that it's useful, and then you measure performance. And so hash tables, filters, there are lots of papers in these conferences about isolated data structures. Prashant has written half of them, and I think Helen has written the other half of those. And then systems conferences, here you build whatever you're going to build, in my case a data structure, and then you have to include it as part of a complete system. And then you have to measure end-to-end performance. So there's these different standards, and also, I should say, different amount of work. These papers are, by the standards of theoreticians, a metric shit ton of work. They will take a large number.
You don't need to do end-to-end performance?
almost never. How many papers do you have with end-to-end performance, Prashant, as part of a complete system? None. that was his nice way of saying none.
Okay.
Prashant and I have a submission to Sigmod right now, and it's about a filter. And we measure its performance, and no one complained about the performance. But they said, oh, no, you need to include it in a complete system and measure end-to-end performance. And literally every co-author was like, did this person just get confused and think that they were not referring for Sigmod? That's not the standard at Sigmod. We're like, in the rebuttal, shall we give them 30 citations of other papers on filters where nobody does this? But of course, we're going to promise to do it because, you know. All right. So what is the consequence of this? It says some consequences. The consequence is that deep down inside, when you talk to a systems researcher, they have this assumption that data structures or algorithmic stuff rarely translate into overall system performance. No matter how good it is, no matter how smart you are, they're just going to be highly skeptical. And they might say things that don't sound like, I'm skeptical that whatever you're thinking about is going to help, because most of them are polite. And they don't want to say, you're smoking crack. They want to say stuff to discourage you. And it comes out as something like, sometimes nonsense, because they're trying to be too nice. If they were less nice, then they would just say what they mean, and then there'd be less confusion. So don't start arguing, because they haven't told you what their real objection is. This is their real objection. So, and this is even leaving aside a healthy disdain for asymptotic notation, right? So you have to look for very large potential wins. 10% improvements are not going to do it. So that you have some chance of affecting the overall system performance, right? I'll give an example where we had a 200-fold improvement that was on the table. And we'll see a little bit about that. If you talk to someone about, look, there's a 200-fold improvement, maybe they think that you could have some impact at the end. They're not sure, but it's conceivable at that point. And by the way, interrupt me all you want. Obviously, this is a fairly informal talk. Yes.
I mean, it's not a question. I call what you just described weaponized Amdahl's law.
Yeah.
Okay.
That's what I call that.
Weaponized what?
Weaponized Amdahl's law.
Oh.
Yeah.
All right. So first question you need to ask yourself is, who owns the research? What does that mean? I'm going to give you a little anecdote of something that literally happened to me, and I'm quoting as well as I can remember, when I was a fresh professor talking to a very senior biology professor. I said, hey, want to work on some phylogenetic stuff together? He was a geneticist. And he looked at me, and what did he see? He saw free labor. So he said, oh, I have some code. Maybe you can optimize the inner loop. And I'm a professor, and I'm peeved. And so I said, while I'm doing that, maybe you can tidy up the plants around the computer science building. I actually did say this to him. And then he got angry and said, oh, and ChatGPT forgot that he had a mustache. How dare you say to me basically the same thing that I said to you, right? According to him, this was a perfectly acceptable thing to say to a computer scientist because he's a biologist, and biologists are involved in understanding the most fundamental things in nature and blah, 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 and we are computer scientists, and they can't tell the difference between us and the IT support people. They don't know what it means to do an academic paper in computer science, and so all he sees is free labor. This was a failed interaction. And maybe not everyone is as big a bitch as I am, but you might feel some kind of way if this is what they tell you. And my advice is walk away. So the owner of the research is determined by the success criteria. When, yes?
Someone who's more polite.
Uh-oh.
But I just want to say you're exactly right. I mean, even if you, so for people who are more polite, that's still, this is the biggest problem, and it can be overcome sometimes, but you have to be aware of this when you're talking to someone, that feels that they're looking for a database hacker or someone to fix,
And when you say polite, you mean compared to the biologist, because of course all I was doing was holding a mirror up to the biologist and saying, look at yourself in the mirror. I was perfectly polite. I was the hallmark of politeness. All right. The owner is determined by the success criteria. For example, if you're working with a biologist, if you have work that has no new algorithms and no new biology, then that's called not getting any research done, and who cares? And if you have new algorithms and new biology, then everybody wins and hooray. If you have no new biology but new algorithms, then this is algorithms research with a veneer of biology. You know the string matching papers where they'll say, DNA is a string. Now let me define this problem that has nothing to do with DNA, right? But a lot of it is going to be that the success criterion is if you achieve new biology, and who cares whether you have new algorithms or not? And if you're doing that, you're doing biology research using computers. And you can choose to do that, but it's a choice. And if you want to be a computer scientist, this does not make you a computer scientist. That makes you a biologist in training, which is fine. It just needs to be a conscious choice. Questions? All right.
I have a question.
Yes.
About the lower right corner.
Yeah.
Well, everybody wins. Who owns it?
What you do...
Because only one party can own it.
No, that's not true. You write the algorithms paper and you write the biology paper. And you put co-authors on, the biologists on the algorithms paper and the algorithmicists on the biology papers.
If you submit that type of proposal to NSF, who is going to review that type of proposal?
Great question. You submit 2 proposals.
I'm trying to get it from the community. I'm wearing my hat.
You submit 2 proposals and you put different spins on them so that the problem statements don't overlap.
I think often what happens is, and this is not about biology, but in other areas versus CS, is that so there might be a new algorithm or something, targeting that area. But people in that core area, bio in this case, would care less about that algorithm if they were not able to do something with it. And you see a lot of claims that people make. Oh, I have this new algorithm for doing this and that and so on and so forth. But that has no impact whatsoever.
That's firmly in this quadrant.
Exactly,
yeah, 100%. People are skeptical for good reason. All right, so now some positive examples. In computational biology, I had this software package, it's still around, called Notung, and it does this mumble, mumble, mumble versus mumble, mumble that I'm not going to tell you what it is, and so who cares? It does some biological computation, and it has lots of citations, and almost all of them are by biologists who are using it. So I count that as a successful outcome. And it's collaborative work with Danny Durand, who was a postdoc of mine. She's a computer scientist, and she's in the biology department at CMU. So I was brought in as an algorithms hired gun. Danny had already reduced the problem to like a combinatorial thing, and I came in and said, oh, well, you do blah, 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 blah. And so I didn't have to talk to any biologists. And let me tell you, I have an MD. I studied a lot of biology. I can talk to a lot of biologists, but I just don't like to be used as as the hired help. So the success criterion here is biology. But on the other hand, I didn't have to commit years of my life to it. I came in, I came up with an algorithm. So that was a good outcome for me. It was like fun and brief. And even though it wasn't really computer science, because the success criterion is biological, I enjoyed it and I got a lot out of it. So another one that is a reasonably positive example, in sequence assembly at the end of the 90s, they were finally having the Human Genome Project. They had these chunks that they had sequenced, and then you had to finally assemble them into one final human genome. And so we came up with this tool for finding some things called chimeras, which were mistakes. And then we removed the chimeras from the data set, and then the assemblies got really much better. It turns out that everybody's assembly methods worked if you remove the chimeras, and if you didn't remove the chimeras, nobody's worked. So finding the chimeras was critical, and we're the ones who came up with the method for doing that. And the chimeras that we found were removed from the official data set of the Human Genome Project. They published what the actual the contigs were, and then they just removed the ones that we found were errors, and then everybody's method started working, so hooray for that. So why was it a reasonably positive example? Because I had sent my graduate student for an internship to the NIH to work with a former postdoc of mine, and she decided that she needed to go tell all the biologists who worked on this at the NIH that they were stupid because they should have known that they were doing everything wrong, and interval graphs are a way to find chimeras, and how dumb were they to have these chimeras. And when I found all of this out, it was a little too late. And so, yes, our work cleaned up the data, but no one was interested in saying, oh, and this paper by these people are how we found out, because she went around pissing everybody off. Why? Why should they know what an interval graph is? They're biologists. So the moral is you have to respect each other's area of competency. And going around and telling people that because they don't know a thing that you know, that they're doing everything wrong, is a way to piss people off. She continued to piss people off until she became a Buddhist nun and no longer does computer science. All right. So,
wait. Maybe you can find out the
I've been
What's the moral lesson?
respect each other's areas of competency. And then there's a big problem when interacting with people, the curse of knowledge. One person will say, what if we use insert acronym here? And maybe this person is like, what? And you're thinking, I don't want to insult them by implying that they don't know what acronym is. That might be condescending. But of course, this person would be happy to explain what it is. So they're thinking, oh, everybody knows what that is because I know, and everybody's smarter than me because I have imposter syndrome. So I'm just going to throw that out there, and then I'm going to wait for questions if the person's going to ask questions. And then the person can think two things. I don't know what that is. They're calling me dumb. This collaboration sucks. And that's what happens if they have mild imposter syndrome. And the other thing they can say is, I don't know what that is, so it must be something boring. This collaboration sucks. And this is what if they have severe imposter syndrome. And I should tell you, in my experience, this is what systems people tend to think on average, in my experience, when a theoretician does this. And this is what theoreticians tend to do when a systems person does this. So take from that what you will. All right, another positive example. BetterFS is an experimental file system that answers the question, what happens when you replace all the bad data structures that people have been using in file systems with good data structures? And that project showed that a lot of file system trade-offs that people thought were inherent to file systems were just the consequence of using the wrong data structures. And one of the things that we'll return to as a theme is, one of these papers got a best paper at FAST, which is the top file system conference, and 3 more got best paper finalists at FAST. It was a series of papers, and people really cared. So the point is, if you address problems that systems people care about, they'll care about your paper, even if the tools and approaches are totally new to them. Systems people are working on problems, theory people are working on techniques. And so if you solve their problem using any technique at all, the reaction by them is you have solved the problem.
But
yes?
This is not a collaboration, this was just you guys, right?
Oh, 100%, there's no way I could have done this.
This is an army.
This is an army of, there were a large, raise your hand if you were on any of these papers. You were, yeah, we had operating systems people, we had lots of students. This was over the course of like 8 years. There were theoreticians and there were operating systems people.
Like 30 people went through that project.
Yeah, it was a big multi-year project with lots of papers. Yeah.
Where did the funding for that come from?
It came from the NSF.
Okay.
We didn't have, so most of it came from the NSF. A small amount of early money came from DOE. Yeah. And a lot of it was theory proposals with strong motivation towards file systems, but with asking real theory questions. And others of it was systems proposals. Their challenge was that our promises sounded too extravagant. So even though they knew that we were going to get a very large speed up, they promised a small speed up because no one would take them seriously if they actually said what we achieved.
And who owned this research?
There were a lot of systems papers.
So it's systems paper.
And there were a lot of theory papers. And it was a lot of fun. So if you're having fun, then I guess that's the main thing.
I feel like everybody owned everything.
Yeah. Well, and there's literally the fact that the software that was underneath this was the software from my company, because we made it open source 6 months before selling it, and so then we got to reuse it because file systems are just databases. And so we use database software underneath the whole thing. So, yeah. All right. Everyday versus speculative research. Mosaic is a project involving a new hash table scheme for hardware design. And yes?
A quick question. So, like in all of these examples, do you think the success is highly guaranteed if you have at least one person in the group who understands both?
Well, success is never highly guaranteed. I'll reword your question to a less Pollyanna one. Do you think that it's required to have someone who understands both? I don't think that anyone at the beginning started out understanding both for better FS, and then there were some people who got to be glue, but they developed into the role of being glue. I think that it was successful because everybody enjoyed each other's company, and because the theoreticians involved thought that the operating systems people were smart and vice versa, and so everyone was highly respectful. And so then we just started talking. It actually started when the operating systems person said to one of the theoreticians, I read one of your papers and I want to implement it and put it in the kernel. Now, I was on all of these papers. I still don't know what a kernel is. The answer to the question of either this is impossible in the kernel or this is trivial in the kernel, I have to flip a coin for it to this day. And Rob can vouch for that. All right, Mosaic is a project involving hash schemes for hardware design. Rob is going to give a talk on this tomorrow. And it started when Sudarshan, who's an OS person who was at Rutgers, and Abhishek, who's an architecture person, who in those days was still at Rutgers, now he's at Yale, and I used to be at Rutgers, and Sudarshan was a new person, and so we thought the three of us should just start talking. We didn't know what to talk about until we finally came up with something to work on together. And so we just met every week for more than a year until finally something gelled, and we just committed all this time. And then finally it was TLB designed. There was one hiccup, which is that young Sudarshan, who is a brand new assistant professor, had a certain point of view. So I said, oh, I propose that we destroy TLBs in this particular way that will have consequences that are unknown to me. And then he would say, oh no, that would break Linux in some arcane way that is certainly you don't understand. And then it's like, certainly I don't understand how it would break Linux. And also, I don't care. Because this research that we're doing is for big swings, unfortunately to use a sports metaphor. You just keep on writing, in addition to this research, standard systems papers that will get into the good systems venues because they are within the genre of standard systems. And I'll keep on writing standard theory papers, and we'll do that on our own time. But for this weird collaboration that we're doing, we're going to end up with weird papers. Where, yeah, if you write a paper where you say, oh, you're going to have to rewrite Linux to get this to work, most of the time, that's a very hard sell. And so that was the kind of thing. You have to get out of your comfort zone of writing the papers that get you tenure, in his case, or get me, I don't know what, in my case. You know, weird collaborations call for extravagant papers. This paper has 16 co-authors, and it took 2.5 years of hard work. And then it got a best paper at ASPLOS. So, I'm not gonna, and then it also, who owns it? It led to a whole slew of Foxdoc Soda, JSDM papers on hashing, and on tiny pointers, and it created this whole very gratifying chunk of theory results as a consequence of starting 100% with TLB design. I had never heard of a TLB when this started. And I would never name it TLB, it's a terrible name. All right, so I'd like to talk about one project, Tokutek, from theorems to customers, and I'm going to talk about it in a little bit of detail. What is my pre-Tokutek context? Pre-2000, I mostly worked on string algorithms with some comp bio stuff, and external memory algorithms was a sideline, just sort of when it was relevant to string algorithms. And then from 2000 to 2002, I was at Google, and the only research, this was the no research allowed period of Google's history. And so I had an hour-long commute from San Francisco to Mountain View and an hour back. And that was the only time I could do research. It was on the phone with Michael Bender. And also at lunch with Moses Charakar, because he spent a year at Google. Because we were not allowed to do anything that would generate publications of any kind during work time. But then I left in 2002, and I got much more interested in large data, external memory algorithms, and so on. And in general, I wanted to talk about the state of the world before Tokutek, and sort of in prehistory. Raise your hand if you know what OLTP versus OLAP is. Wow, very few of you. It used to be a very big deal in databases. OLTP is online transaction processing, so you can support insertions and usually short transactions, and you can only support point queries. And then in '93, Edward Cook introduced OLAP, which should be called offline analytical processing, but got called online analytical processing. Should be called offline because it's offline. And this supports bulk updates and the maintenance of multiple different orders on the data. Maybe one is sorted by date or by age or by social security number. And so you can do long range queries on these different orders, and those are called analytical queries. And so you can think of this as like the database that handles the retail part of a bank. And this might be like if there's an investment branch of your bank that's trying to find investment opportunities and doing big data-based queries, that's OLAP. Now, people used to think that there were OLTP workloads and OLAP workloads, and that this was reflective of actual customer interest. And I don't think that. Let's take the negative view. In OLTP, you can't have multiple indexes of the same data because it's too slow, and therefore you can't do range queries, and large transactions kill your performance. And in OLAP, you can't do incremental updates, so all your data is always stale, and you can't really handle high volumes of transactions. So this is it's defined really, these categories are defined by what they can't do rather than by what they can do. And so no one ever went to a database company and said, if I want market analysis done on my transactional data, I want to have to transfer it into an analytical database. That's the thing I want. I want to do this extra work so that I can ask these queries. Or I want my analytical database to always be stale because I can't update it in real-time data. These are not customer demands. And so I think it's an artifact of a data structural choice, the B tree. That's my cartoon of a B tree. Can you tell that I went a little crazy with ChatGPT? And here's another thing. Michael Stonebraker won the Turing Award in 2014, and they said a bunch of things about him. And one thing they said was in 1999, since 1999, Stonebraker has co-founded a company every few years focusing on the development of database management technologies specialized for particular areas, such as blah, high throughput transaction, VoltDB. However, one of his latest ventures focuses on handling massive arrays of scientific data, departs from the relational model. So there is this belief that the only way to get real performance was by having specialized databases. And Michael Stonebraker has done a lot of stuff in databases, but this was this sort of pushing this view that you needed specialized databases was a big reason that I believe that he won the Turing Award. So his insight, in my view, is that since B trees aren't great, you can build a variety of specialized databases that can outperform a general database in each of many domains. But that leaves the question, what if you could substantially outperform a B tree in general? So now we have these two consequences of B trees that were central to database thinking. One is that OLTP versus OLAP is a natural distinction. The other is that you need to have specialized databases to get any kind of performance. So you can outperform B trees. And before we do that, what's wrong with the B tree? Do you raise your hand if you know what a B tree is? Most people do. And when I say B tree, there's this embarrassing distinction between B tree and B plus tree. And it's just a homework exercise. They're both B trees. Give me a break. So I only call them all B trees because I'm embarrassed for the database community for making this distinction. All right, so it's a B-ary search tree where B is the transfer size of memory, and so the depth of this tree is log base B of n, and so insertions take log base B of n IOs. And so on real systems, this can lead on some workloads to much less than 1% of disk bandwidth, right? You basically are horribly bottlenecked by IOs, and you can't really insert data very fast into a B tree. So sequential insertions are an exception, because if you have a sequential insertion, you're inserting into a leaf, and then the next guy goes into the same leaf, and into the same leaf, and you have everything cached. And so you don't have to do IOs to do, very often to do sequential IOs. And so you can insert many guys much, much faster. You can do sequential insertions at near disk bandwidth. All right. And then batches are fast, and I'm actually running shorter on time than I would like. So if you batch things up, you sort them and insert them in sorted order. And if the batch is long enough, you get some locality, and so you can do batch insertions pretty fast, medium fast. All right. So how did databases used to be designed? And someone's going to say, no, what about the left pinky ring on this design? This is a gross oversimplification. You had two choices: make all insertions sequential by inserting them in the order of arrival. And then this order is meaningless for most queries. And so you can only handle transactions, but queries are extremely limited. And in other words, you get OLTP. Or keep data sorted in several orders that are useful for common queries. And then if you have several orders, they're going to not look sequential. And so then you batch up your insertions to make the batches big enough that you can then insert them fast enough. And that's called OLAP. And that is the two big ways to build. And I actually went to my investment bank and talked to the head database guy. And they'd turn off their database in those days for all of Sunday so they could update their database, because they needed analytical databases. So Sunday was no database day. All right. So OLAP versus OLTP is a consequence of random versus sequential insertion gap in B trees. What about specialized databases? We'll get back to that. And so what's the alternative? Well, so Michael and Bradley Kuzmal, the third founder of Tokutek, were at a HEC-IWG file system I/O workshop, which is some DARPA thing, I believe, which is why I put them in a uniform. And they've stated a grand challenge for file systems: create 30,000 microfiles per second. In high-performance computing, you sometimes create tiny files that are empty as locks and semaphores and so on. Traverse the file system recursively at disk bandwidth. And then how big a supercomputer does it take to achieve those two things? And this is an OLTP style constraint, and this is an OLAP style constraint. Why? Because no one wants OLTP or OLAP. Everybody wants the best of both. So here's Michael and Bradley that night. And Bradley had been thinking, I want to start a company doing cache oblivious stuff, because the three of us had been, he's a theory adjacent systems person. And he was thinking, and we had been doing all this stuff about cache oblivious. If you know what that is, great. Otherwise, external memory algorithms. And I want to start a company doing that stuff. And then he said, how do we solve the grand challenge? And then Michael came up with a data structure. There's the cartoon for the data structure. And then Bradley said, cool, but there's a lot of work to do to make this full-featured. Like, you'd need a brand new technique for handling transactions, for example. The way you handle transactions in B trees wouldn't work at all in this data structure. And so then Jeremy Feynman was there, and he unlike the rest of us, he actually reads papers. And so he said, that's called a b to the epsilon tree. And yeah, that's the joke. And so that's by Brodel and Fagerberg, 2003, which is just a parameterized version of this thing called the buffer repository tree from 2000. So yes, everybody knows about this data structure, except for you guys, because you don't read enough papers. And so then Bradley coded it up that evening. And he measured random insertions in a b to the epsilon tree versus Berkeley DB, no offense to Berkeley. And so Berkeley DB is pretty fast until it runs out of memory, and then it slows down by 2 orders of magnitude or more. And a b to the epsilon tree does not. And so they figured that you could solve this grand challenge of DARPA's on a laptop. You don't need a supercomputer. You just need a better data structure. And it closes the gap between random and sequential insertions down to around a factor of 2 from around a factor of 400.
Is that your factor of 200 you mentioned before?
Yes, that's exactly what it is. So Michael said, let's start a company. This could be useful in lots of situations. And then Bradley said, great. And then we're going to solve all these algorithmic and engineering problems that really there's going to make a lot of work, but it should be a lot of fun. And so then Michael said, time to call Martin. And they called me, and I said, let's call it Tokutek, which is some absurd pun involving Japanese, French, and English. I'll tell you what it is, the pun is. Toku means hide. It's one of the things that it means. Hide in French is caché. Caché moves to English as cash. And everybody can spell it. So there you go. That's where Tokutek comes from. And so we started in 2006. We had our big funding round in 2008. My recommendation is don't raise money in 2008 for future reference. And then when we ended up with customers like Walmart and Cisco and a bunch of other ones, and then we sold it in 2014.
Did you say one sentence about what the product was that Walmart was buying? Or?
A database that was fast for random insertions, and so you could do analytical queries on up-to-date data.
So they downloaded some software on their laptop and ran it? Or?
Yeah, basically the first product that we did was backend for MySQL, which they were using internally a lot because it's much faster than, like what do IBM and Oracle offer as products? They offer databases that are slow and so hard to use that you have to hire people internally who become experts on that, and then it's their job to make sure that you continue. They're the sales reps for continued use of Oracle and IBM. And so then if you actually want it to have only bad performance, you switch to MySQL, and then you swap out the back end, and we were completely compatible with, yeah. So this is the world post Tokutek. Of course, everything got better. And then, so the legacy of Tokutek is we were the first database that used write-optimized dictionaries, which includes b to the epsilon trees and log-structured merge trees. What's a log-structured merge trees? It's like a b to the epsilon tree, only worse. Why do people use them? Because the current generation of database architects and systems architects were in graduate school when log-structured merge trees came out. And so that's what they know. And nowadays, all new databases use this. So what about OLAP versus OLTP and specialized databases? So now if we stopped using B trees and started using WADs, did we fix all of that and did it all go away? Well, the way I figured that out is I analyzed all database companies that got funding in the last couple of years, and they fell into a few categories. LLM related, not surprisingly. Databases that have specialized relational data, like data from the energy industry. So what they're really selling is access to this data and not database technology. Distributed databases, databases that reduce the human effort to use them. Like it's easier to code up stuff, or it's easier to configure it for different settings. In memory, so this is the only type that talks about transactions in OLAP, and it was a Stonebreaker company. And then graph and high dimensional databases, which are the only specialized data type databases. These are not relational kinds of things. Yes?
I'm surprised columnar didn't come up. Has that just died out, or what? Did you see that at all, or any evidence?
I didn't see any evidence that was being funded right now.
There's some open source like DuckDB and all, but they're not.
The experiment is I looked at the list of the companies that were listed as having gotten funding, and they all fell into these, and there were only 2 examples here and only 1 example there.
Interesting.
Yeah.
So, Martin, where do you find a list like that, and how do you know whether it's complete?
Yeah.
I didn't know if it was complete.
But just
There are industry websites that talk about these sorts of things.
so like venture capitalists publish, we just made an investment here,
Yeah.
and somebody collates those.
That's correct. And I looked for the keyword, and then they get categorized with keywords, and I searched on the keyword database. That is one of the tags that
Was
they
that like an
pre-populate.
OLAP search or an OLTP?
Well, neither anymore. It's post-Tokutek time. Let me just tell you what happened with our very first customer, which is Kayak, the company that you use for finding travel stuff. And they had analysts that were trying to find travel deals. And those analysts wanted indexes into the data, and the database administrators would hear competing cases about the choice of which indexes to maintain because they had OLAP queries. And they had to make very tough choices about which indexes they could maintain. And the decisions were made at a very unpleasant weekly meeting. And it's so unpleasant that ChatGPT decided this guy couldn't even face the situation. I could not get ChatGPT to turn him around. All right. So then they started using our stuff, and after a month, database admins concluded that they could maintain about 200x more indexes with the same resources other than, of course, disk space, which is why we implemented compression for them. And then they started saying yes to all of the requests. And then everyone got happy. Somehow she's still looking away. And then after another month, the database administrators concluded that this meeting, like most meetings, were a waste of time. And they just allowed the analysts to start adding indexes. And all they do is run some background script to see which indexes were no longer being queried. And then they shut those off. So this is the conversion of an OLAP workload into an OLTP workload. Why? Because no one wants OLAP or OLTP. They want both. Yeah, I just said that. And so they want databases that are fast at indexing and fast at querying. All right, what about specialized databases? Showed that there's no evidence that they're really being funded. And so I think they're clearly less prevalent, but definitely not dead. And I came up with a visual analogy for this. If you have a very dim bulb at the center of a room, you might need flashlights in order to find what you're looking for. And here's your B tree-based database, and here are your specialized databases. And then you get a bright bulb, which is a write-optimized database. And then your flashlights, you might still need them sometimes, but they're generally a lot less useful. And this is exactly what I think has happened to the specialized database landscape. Okay. So the big picture is it's key to use the best database, even in complicated systems like databases and file systems, where you think that all kinds of system stuff will hide your contribution. And I think that algorithmic research can be much more useful than you think. Of course, we were starting out with a 200x advantage that we could gain, but we gained all of it. All right, so you've worked with systems people and you've figured out something really cool. How do you start a company? Step one, you file patents.
Can I ask a question?
Yeah.
I'm sorry. I mean, what was interesting about the kayak story is you started off with a 200x performance improvement, but then the actual benefit you described to the people working there was they got to stop having a meeting.
Yeah.
Is that
It's the coin of the realm. Insertions or the databases will improve everything. It'll make vegetables tastier too.
But is that commonly was that a common phenomenon that you saw, like where the thing people actually cared about was not performance, it was like something else that you somehow could buy with performance?
Yeah, I don't know that I have a pithy thing to say about that.
Okay.
Yeah. But I will say that people think, oh, you're improving insertions, but what people really want is faster queries, and definitely faster insertions are money in the bank that you can spend on faster queries. That's 100% true. Yeah. All right. File your patents. If you're a professor at a US university, your university owns your intellectual property. So if you want to start a company, you need to convince your university to patent your idea. And at most universities, if they pass on patenting it, you can patent it yourself, and they don't own your patent anymore. And nowadays, that's costing about $25,000 to do. So if this is the path you're going, you have to feel confident to the tune of $25,000 that you're going to get somewhere with this. If you're a student at most universities, you already own your intellectual property. They don't own it.
Like grad students or undergrads, or sometimes they have different policies.
Sometimes they do, but I was working with Bill Kuzmal when he was at MIT, and I was surprised that he was a PhD student, that he owned his IP. And
I think you better check that.
we checked it, and then I checked it at a couple of other universities, and that was also the case. I'm not saying it's universal. You might own your IP. It also, I'm sure, depends on how you're funded.
Yeah.
Right.
Yeah. And if you're neither, and you're at a company, your company owns your IP, whether they patent it or not. Never, if you think you're going to work on something that could be commercially viable, first of all, don't work with anyone at a company. And if you have to, definitely don't work with two people who are at two different companies. We were going to patent the Mosaic stuff, and one person was at VMware, and another person was at the anti-democracy company. What's it called? Meta? Yeah. All right. So there was no patenting something where two of the inventors were at different companies. Yes?
25K, then it is 100% yours.
At most universities, the ones that I checked, if they say, we won't patent, you have to do a good faith effort to convince them to patent it, and then if they pass on it and you patent it, you own it. All the inventors own it, I should say. You can't say, well, I'm paying for it, so my co-inventors don't own it. Nope. It has to be all the people. Now, if it becomes valuable and they go back and say, you didn't really make a good faith effort to convince us, you hid how good it was. So no, you have to be extravagant in your praise of your own research so that you cover your ass. And since all professors are always extravagant about talking about their research, they are unlikely to be convinced. And then you're $25,000 worth of home free. Yes?
If the university files the patent, they own the patent.
We're getting to that. Suppose you have collaborators, and for the sake of argument, just as a hypothetical, suppose those collaborators are the three people are at Rutgers, Stony Brook, and MIT. And suppose that at least one university agrees to patent the idea. Usually the universities will be smart enough to split the cost. Who owns the IP? The bad news is that each university owns 100% of the IP. What does that mean? We'll get to what that means. And why is this bad news? If you start a company, you need to license the IP because you don't own it. So you need to get exclusive rights to use your own intellectual product because you don't own it anymore. And they'll want equity in your company, which we'll talk about. So let's go ahead and work out what happens when 3 universities own IP. I said it was bad news. Each can license the IP without consulting the other 2. They each have a 100% right to license it to whoever they want. You want an exclusive license. So you could play them off each other and see who gives you the best deal, but then you don't want to because that would leave the other 2 with the ability to license it to someone else. So you want all of them to license it exclusively to you. So it's important that step 1 be to get your universities to sign an agreement that they will license only if they agree, and then they'll split the proceeds. So usually the way that works is one university gets to license it, and they split the proceeds 3 ways. Yeah?
So did I understand that even if only one of them chose to patent it, they all own it?
Yes.
Well, great.
If you and I work and I spend the $25,000, I still have to put you as a owner, as an inventor, and you can go and license it to whoever you want.
Martin, maybe you'll come to this, but you started off by saying, step 1, file patents.
Yes.
You didn't say, like, the alternative would be, we're not going to file patents. We'll let a year pass, and now patenting after publication, say, and now it can't be patented, and we'll start our company without patents.
That's the CMU way.
Well, no, just asking, like, why do you think it's better to file patents?
Okay, so we all know that there are the big 4 universities in computer science, and if you're at one of them, you can convince someone to give you money on the promise that you'll patent stuff later on. And if you're not at one of those universities, that proposition becomes much, much more difficult.
So why does an investor care about patents?
Because their friends do.
They feel like you must have something that no one else can do right.
That's right.
So
they want to protect their position as much as possible.
It gives your company some credibility.
That's right.
That's the reason.
That is the reason. Okay. So rule of thumb, the better the university, the less of your company they want, because they're just playing the odds. And so if you have Rutgers, Stony Brook, and MIT as owners, you get Rutgers and Stony Brook to agree that MIT runs the show, and they each get 1/3 of the proceeds. And why do they agree to this? Because they don't know that MIT is going to ask for less than they asked for. And don't tell them. Another rule is you are not allowed to negotiate with your university because there's a conflict of interest. So you have to hire someone to negotiate on your behalf, and you tell them what to say, but you can't be the one negotiating. And normally, because you don't have money at this phase, you give them some equity to do this work for you. So step 1 in the negotiation is read the book Getting to Yes, where you'll learn about, I mean, it's one of these books that would have made a fantastic 30-page article, but they had to jam it into 200 pages because you sell for more money at 200 pages than at 30 pages. But you learn about positional negotiation of split the difference versus principled negotiation, where what you're negotiating is how to determine a fair price. So we were going to do principled negotiation. We took the median of the last 10 similar deals MIT had made and offered them 3% of the company. And for reference, Rutgers and Stony Brook wanted 10 to 20% of the company. All right.
Which means they probably don't have a lot of companies spinning off.
100%. So we said we'd like a principled negotiation, and the MIT person said, what the hell are you talking about? Because he had not read Getting to Yes.
Harvard thing.
Yeah, we took the median of the last 10 deals. We'd like to offer you 3% of the company and just be done. He said, we'll take 20%. Like, no deal. We won't make a counteroffer to that. Why not? Well, because if we give you 20%, we're chumps. And then no VC will ever give us money because we are not credible stewards of the value of our company. We just look like fools. And no VC wants to invest in, no matter how good your technology is, you're just a dunce if you do this. So no counteroffer. But this patent's so valuable, they answered. This is all what actually happened. It's our patent. We know how valuable it is. It isn't worth 20% of the company. Okay, 10%. Now, there's this scene in the Maltese Falcon where what's his name? Humphrey Bogart is negotiating, and the first person to lower their price, somehow then Humphrey Bogart has a little smile because the other person blinked. And this is MIT blinking. So there I am smiling. It's not actually me, it's the person we hired. Okay, 2.9% was our literal counteroffer. But that's lower than your previous offer. Yes, the way we calculated that is it's 3% minus the discount for wasting our time. So 2.9%. 4%. 2.8%. 3.5, and that's our final offer. Let me talk to your boss. We Karen'd the situation. The boss shows up, and she says, what's the problem? Well, your guy is jerking us around with offers from 20% to 3.5% with no explanation. He's just like, what the hell way is this to do business? What was your final offer? 2.8%. Okay, 2.9%, take it or leave it. Done. That's how we negotiated with MIT. What do you learn from this besides the fact that we felt awfully smug? Is you hold all the cards in this negotiation over licensing with your university. Do not let them bully you. Fuck them.
By the way, another thing you could have said, which you didn't get to, is we patented it. We know how to work around it.
That's also true, but that would actually put you in violation of your employment contract.
Well, you can start a company and not use your patent.
That is true, but you can't say that you're going to work around the patent that you've given them. You have to negotiate. You have to do the patent stuff in good faith.
No. What I mean is, after all that's done, you filed the patents.
Yeah.
You want to start a company. Your negotiator could say, why should we pay 20%? If we have to, we can work around the patent.
That's true. All right, raising money. I'm not going to talk about all of it, but there's early stage called angel investors, which is like hundreds of thousands to small number of millions of dollars. It helps to have been an employee number 110 at Google, so you have a bunch of friends who also went through the IPO, and that's who our angel investors were. Nowadays, it's more formal than it was. And this part's less formal. Once you get to the VCs, things get interesting. What is the most important thing for the success of a startup? Any ideas?
Timing.
Haha, timing is important.
Customers.
Yeah, but like things under your, like when setting it up. Is it the technology?
People.
Huh?
The team.
The team. Which member of the team?
Marketing. Or say.
The CEO. The CEO is the most important person. They're the ones going to be negotiating with the VCs. And here's the thing we found out. What if the CEO looks like this? We literally found this out. This is a person that a VC will not listen to. And then one day, after talking to several VCs, I said, I'm taking you shopping for clothes, and I don't care what you say about it. And I made him dress like this. And this is a person that a VC will listen to. After that, it matters what they say, but they need to look like a VC, and they don't need to look like a schlub. Now, the technical founders can totally look like this, though I really don't recommend pleated pants. All right, presentation isn't everything, but it is almost everything, and this is a true story. And then, of course, once they're listening to you, you have to have good things to say. Unless you think, oh, VCs are so superficial. Imagine someone sent this to Fox. Would that get in? This paper would not get into Fox, almost no matter what it says, right? If it's not formatted in LaTeX, people aren't even going to bother. This was a paper by Feynman in the 40s, right? But we're superficial too. Or what about submitting a paper to SOTA that includes experiments? I have it on I've run the experiment. You submit it with experiments, it gets rejected. You remove the experiments, it gets accepted. And then, because there are no shepherds, you add the experiments back for the camera ready. I've done it before, and people are like, it's so amazing that SOTA takes papers with experiments. No, they don't. I'm just an asshole. All right, so rules for talking to VCs, we've got to be careful how you dress. And then number 2 is never contradict anyone from your team during a presentation, even if they are wrong. You can say, oh, yeah, that's an excellent point. I totally agree. And then immediately contradict them. It always has to be, yes, great point. You always have to be positive. I am positive they are wrong. You have to be ready for, here's the smug VC. You have to be ready for bizarre comments and questions. These are all real situations that happened. How many founders do you have? 3. 2, that's too bad. Statistically, 2 founder companies do better than 3 founder companies. Now, it is my belief that almost all of this just reflects the success of Google, and that totally warped all the statistics. But even if that's not what it was, this is literally an interaction that we had. If you have nothing nice to say, nod as if they said the most clever thing ever. Our technology can be used for databases or file systems, but databases are a bigger market, so that's our go-to market. But once we've made a lot of money there, it is conceivable that we could have a secondary product in the file system space. Oh, so you can only be successful if you have both a database and file system product. This happened with 4 VCs. Why did it happen with 4 VCs? Because I could not believe that they were saying this, and so I just kept on putting my finger in the socket over and over again. No, forget I said anything. No, I understand. You don't win. If you don't win in 2 markets, your company is a failure. This reminds me of I was buying my first apartment when I first was a professor, and I went to a mortgage broker and I said, oh, and one of the cool things is that I have 6 years of guaranteed employment. No. Oh, well, then what happens? Oh, well, then I go up for tenure and I either find a new job or I have lifetime employment. Oh, so you only have employment for 6 years. And I said, well, how much guaranteed employment do you have? What do you mean? If I leave, could your boss come in here and fire you on the spot? What? I had to find a new broker and not say that I had 6 years of guarantee. This is the same thing. Don't say anything that is even positive if it's like even slightly. Never mention file systems. Or keep the message simple. Where does the name Tokutek come from? It's a twee pun involving Japanese, French, and English. Tokutek means profit. Toku means profit, which it also does. I like that. Keep the message simple. Final thoughts? When you do this kind of research, it's panic-inducing to give talks outside of your area. You've you've trained yourself up in combinatorial optimization or randomized data structures or whatever it is, and now you've used it in some area outside of your area of comfort, and you've done it by working with wonderful collaborators who are experts in that area, and now you give a talk, and you're supposed to be able to answer questions about what a kernel is. And you can't. So it is very upsetting and panicking, no matter how senior you are. This is very frightening. What if you don't know the answer? It's okay to defer questions when you're doing cross-disciplinary stuff. You're just going to have to get used to being uncomfortable about that and just saying, oh yeah, that's a great question. Can I follow up with my co-author, and I'll send you an email. Because you don't know the answers. Like, they are experts in things that you don't know. All right, there are big cultural differences between systems and theory. Every systems paper has a bogus theorem. And you're like, what is this theorem? First of all, is the proof even right? And is it even a theorem? It has nothing to do with the problem they're solving. There's some prestige associated with having this bogus theorem. Unless you think, oh, those systems people. Every theory paper has a bogus introduction. There's a prestige with saying that your proof that this complexity class is a subset of that complexity class will change the electrical grid, right? So, you got to be sensitive to people's needs. And then the most surprising difference for me in doing all of this work is that people at systems conferences actually care about your results. My experience at theory conferences is they're just waiting for you to stop talking so they can tell you about their results. Theory people do not care about each other's results. We are cats. And systems people are not just dogs, they're hounds, they're pack dogs. You go, you give a paper, you go to the poster thing, people are going to come with questions. Sometimes they're obnoxious questions, sometimes they're interesting questions. They're always interested. 3 days later, at the end of the conference, you're leaving the conference, people are going to come up and ask you questions about your work. Has that ever happened to you at a theory conference? Raise your hand. I defy you to tell me that that's ever happened to you at a theory conference. This is delicious. And also, I can't say that database reviews are universally good, but systems conferences reviews, those people put some work into it. It's crazy. It is amazing. Like, they went and read the database, the data structure literature, or they found someone who knew about data structures to write a very detailed thing about this data structure versus that data structure, and like, what? It's very shocking to me, the extremely high quality of, and gratifying. It's nice to have, I mean, they're also sometimes stupid. It's always referee two's fault. But, it's a much higher standard of refereeing. Thank you. Questions? Unfortunately, I will now be leaving for the airport, but I'll be back for the memory thing.
I'm not going to allow us to follow up with you like 3 days later at the conference with questions about your talk?
You can follow up in 3 weeks. Yes?
Yeah, so probably about the first half of your story. So the problem is that does the improvement only make sense or works when the story is changed? Because what you've just mentioned is that you improve something by 200%, then something
200-fold. Excuse me.
200 times. Sorry, 200 times. Then what actually matters for them is that they are canceling that meeting, and they are building their own indexes. So it seems that I don't know if I'm correct. Is it just only important way to kind of change the story when your improvements are changing the story?
I mean, you probably never heard of the company Sears, but anyone over the age of 45 who's American in this room has heard of Sears. As this used to be all these stores everywhere, and now the stores all closed, and they became a data analytics company for other retailers. That's their business, and they are really, really, really good at it, and they were a customer. And it was not about canceling meetings. For them, it was an extremely technical, like their technology evaluation and Walmart were the best technology evaluations, and the worst was Facebook. You know, so different customers, you have to you talk to the customers, meet them where they are. I did not think compression would matter because disks are cheap and computation's expensive. I was wrong. We rushed to add compression. All of these things, you actually just have to be super responsive to what people actually want. And some people will experience higher performance as I get to cancel a meeting. And other people will say, aha, well, our budget for servers, blah, 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 blah. Yeah, there's no one story. When you have a big technology win, there's not one story. Other questions? All right, well, I thank you for your attention.